Hello friends, today I will discuss about use of Metrosil in case of REF or restricted earth fault relay, and also on the calculation of peak voltage developed based on this condition, whether the Metrosil is required or not in REF relay will be discussed in this video. Before going through this video, you are requested to please go through my channel and also do subscribe my channel and also press bell button for notification of videos to be uploaded in future. Now the connection of the REF relay for star winding or star side of the transformer has been shown in this diagram. In the HV side, P1 shall be connected in the bus side for each phases, and for P2 for each phase CT shall be connected towards the transformer side. Again, for NCT or neutral CT, the P1 shall be connected towards the earth point and P2 shall be connected towards the neutral point. And in the secondary side, all the phase CTs along with neutral CTs, all the S1 terminals should be sorted together and connected to one end of the REF relay, and similarly all the S2 terminals are sorted together and connected to one end of the relay. The stabilizing resistor is used in series with the REF relay as shown in this diagram, and Metrosil shall be connected in parallel with the stabilizing resistor and the REF relay. Now Metrosil is basically a non-linear resistor. It is used to limit the peak voltage developed under fault condition to a value below the insulation level of the CT relay. It is basically used when the peak voltage developed during fault condition is greater than 3 kV. So in this video we will discuss whether Metrosil is required or not for REF relay based on the value of the stabilizing resistor. Now under through fault condition, if a through fault occur in red phase to earth, then the current flow direction has been shown in this direction in this diagram. It is basically a 10 MVA 33 by 11 kV transformer where the CT ratio is 600/1 for phase CT and also the NCT. Now the through fault current is IF. IF will flow from for phase CT direction for red phase is from P2 to P1 direction, and therefore the current direction for secondary side it will be S1 to S2 terminal. Again for NCT, the direction of the current will be from P1 to P2 as shown in this diagram. Therefore, the direction of the current in the secondary side shall be S2 to S1. Now, since the direction of the current in the secondary side or in the primary side, that is for primary side is P2 to P1 for phase CT, which is opposite in nature, that is with respect to NCT, that is from P1 to P2. And therefore in the secondary side the direction of the current for phase CT and NCT is reverse, that is for phase CT is from S1 to S2 and for NCT is from S2 to S1. Therefore the current in the relay shall be 0, and that is why relay shall not operate under through fault condition. Now under through fault condition, if one of the CT saturate, let's consider the NCT or neutral CT saturate. Under this condition, the same current, that is fault current IF, flows from P2 to P1 direction for phase CT, and for NCT the direction of the current will be P1 to P2. But the secondary replica of this current for phase CT and neutral CT will not be same. That is, the secondary replica of the current in the phase CT will be much higher that compared to the neutral CT, and that is why the total current in the REF relay shall not be 0, and which will lead to operate of the REF relay. So under through fault condition, to prevent the maloperation of the relay under the condition that one of the CT saturate, stabilizing resistor, that is RS, is used in series with the 64R or REF relay. Now we will calculate the stabilizing resistor value. Now for this, the CT ratio is for phase CT and neutral CT is 600 by 1, and the transformer capacity is 10 MVA, and it is 33 by 11 kV transformer, and the RF relay is connected for 11 kV side, and it is a stars connected star winding in the 11 kV side, and percentage impedance is, that is percentage Z is 8%. Now the cable connected from the CT neutral CT secondary box to the panel is 100 meter long from one end or one way, and the RCT resistance, that is secondary value of the CT resistance, is 4 ohm for NCT and also for phase CT, and knee point voltage VK is 600 volt for all CTs, and the cable resistance is 5 ohm per kilometer, or it is 0.005 ohm per meter, and relay burden is considered as 1 volt ampere. Now the full load current in the 11 kV side is calculated by IFL in the 11 kV side is equal to 10 into 10 to the power 3 divided by root 3 into 11, which comes as 525 ampere. Therefore, the maximum through pole current is equal to I full load current divided by percentage impedance, which is 8%, and full load current is 525. The maximum through pole current is considered here by neglecting the source impedance, so which is comes as 6563 ampere. Now, since the maximum through pole current IF is equal to 6563 ampere, the secondary reflection of this through fault current in the NCT or in the phase CT is equal to 6563 divided by 600, as the CT ratio is 600 by 1, which comes as 11 ampere approximately. So the stabilizing voltage Vs is equal to If into RCT plus R cable. Since the cable length is 100 meter in one way, since 100 meter and 100 meter go and return cable is used, the cable length will be 2 into 100 into 0.005, comes as 1 ohm. Therefore the stabilizing voltage is comes as 11 into 4 plus 1 is equal to 55 volt. So we know the value of the stabilizing resistance and know the relay burden, that is 1 volt ampere. Now we can calculate the stabilizing resistance Rs is equal to Bs by Is minus 1 by Is square. Here 1 is the relay burden. So the relay setting is 0.1 ampere. Now we can calculate the value of the Rs is equal to 55 divided by 0.1 minus 1 by 0.1 square, which comes as 450 volt, 450 ohm. What will happen if the Metrosil is not used? Now if the Metrosil is not used, then under through fault condition, since the earth fault clear is taking some time and somehow 100 200 millisecond or even more, depending upon the magnitude of the current, the high voltage will develop across the resistance and the relay, and this high voltage will lead to failure of the insulation of the series secondary relay circuit if the value of the high voltage is more than 3 kV. Since the relay circuit and the CT secondary insulation is able to withstand up to 3 kV peak voltage of the insulation. Now again, if the value of the Rs, that is stabilizing resistor value, is more, then the high voltage developed across the relay along with the resistor will be more. If the value of the stabilizing resistors is less, then the high voltage developed under fault condition will be less, Therefore, the use of the Metrosil is depends upon the value of the resistor. So now we will calculate the whether the Metrosil is required or not based on the peak voltage developed under through-fault condition. Now the peak voltage developed during maximum through-fault current, that is Vp, is equal to 2 into root over 2 Vk into Vf minus Vk, where Vk is the knee point voltage of the CT, and here the Vk is 600 volt and Vf is the maximum voltage drop during maximum fault current, where Vf is equal to If into RCT plus RKL plus RS plus RR. Here RCT is the CT resistance, RKL is the resistance of the cable, which is measured as 1 ohm, and RS is the value of the stabilizing resistor, which is calculated as 450 ohm. Now RR is the relay resistance, which is 1 ohm. So the value of the Vf comes as 11 into 4 plus 1 plus 450 plus 1, which is equal to 11 into 456, comes as 5016 volt or 5.016 kV. Therefore, the Vp comes as equal to 2 into root over of 2 into 600 into 5016 minus 600, which is equal to 2 root over of 1200 into 4416, which is equal to 4.6 kV, which is much greater than 3 kV. Therefore, Metrosil must be used in these cases, as the peak voltage is 4.6 kV, to protect the relay insulation and also the CT secondary circuit insulation. If the value of the resistor value is less, then if the Vp comes as less than 3 kV, then Metrosil may not be used in these cases. So friends, now you understand why the Metrosil is used in case of RF protection, and how to calculate whether the Metrosil is required or not during maximum through-fault condition, that is the development of the peak voltage across the relay circuit.